Good morning, guys. Here we are with lesson 4, which is solving inequalities by using adding and subtracting. If you're watching this video, make sure before you watch it that you've watched the first video that I've sent. Again, it's somebody else's video that kind of covers this topic. And so watch it first before you watch this one. If you haven't, back up and do it now. The other thing I wanted to mention, guys, I would like you to send me something. Some people are taking pictures of their work and sending it in to me. Or some people are just sending me back a message saying, "Hey, Mr. Gaddis, I did it all, no problem. I got this lesson done." Or if you're having problems in a certain area, I'd like you to send that back too. So, I might be able to address that before I begin the next lesson. So, this lesson here, I'm looking at example 1, page 296. And what they give me is 6.2 is less than or equal to x minus 4.5. And the first thing they ask me to do with that is to solve it. So that's no big deal. Solving this inequality, same as solving equations. I need to get the x by itself, so I'm going to send the minus 4.5 over with the 6.2. And the minute it crosses my sign, that minus is going to become a plus. So I'll have 6.2 plus 4.5 is less than or equal to x. So it's at 6 and 4, so that'll be 10.7 is less than or equal to x. Or the way I like to write them, you can do it either way. I like having my variable in the beginning. Now I just look at the sign, it's pointing away from my variable here, so I need it away here, and the 10.7. So there it is. X is greater than or equal to 10.7. So I've solved it, the first portion they asked me to do. What do they ask for next here? Verify the solution. All right, let's verify it. So I'll write my question down like I saw it at the beginning. So let me see. I'll start off the 10.7. It said that x could be equal to 10.7. So 6.2 is less than or equal to, in the place of x, I'm going to put in our solution of 10.7 minus 4.5. So, here I'll have 6.2, 10.7, take away 4.5. Came out to be 6.2. So that works because 6.2 is less than or equal to 6.2. Now, I usually do a couple of them. Let me see. 6.2. And this time, in the place of my variable x, I'll go with 11. Because 11 is greater than or equal to 10.7. Take away 4.5. So 6.2 is less than or equal to 11, take away 4.5, which comes out to be 6.5. So there's my verifications. I put in a couple numbers that are larger than 10.7 or equal to 10.7 and check to see that this still comes out to be a true statement, which it is. 6.2 is less than or equal to 6.5, and 6.2 is less than or equal to 6.2. So we verified it. The third thing they wanted me to do is to graph the solution. So here I am. Okay, I'm going to graph my solution. So X is, so I look at 10.7. So I start off with the closest thing to it, 11. I'm going to go a couple bigger, 12, 13, a couple less, 10, 9. So 10.7 approximately is going to land in, there's 10.5, bigger than that. So about here. So that's my 10, and it's greater than or equal to, because of the equal to, I got to color that dot in. And X needs to be larger. So larger goes to my right. So there it is. So in this case, it's saying X could be 11, 11.5, 12.7, 13, and many, many more. So that's example 1. So the questions I want you to do now, page 297. Questions 8 and 9. Now, I did those questions myself, and after a while it seems like they're a little bit monotonous. But remember, we talked about this before. Math is kind of like sports. Remember, we compared it to hockey. Somebody doesn't just teach you to pass a puck once and say, that's it. For the rest of my life, I'm good on passing pucks. You practice it over and over and over, and after a while it becomes second nature. The math's kind of the same way. So try to do all of question 8 and 9. All right. So I'll be back with example 2.